Hello there, Mr. Sutton here, bringing you the BC Calculus 516 Part 1 homework solutions on integration by partial fractions. For this problem, we're trying to find the antiderivative of this rational function. Since I have unique linear factors here and there's no other way to really deal with this or simplify it, I'm going to try integration by partial fractions. So I'm going to take this fraction and I'm going to split it up into a over x plus 2 plus b over x plus 1. And now I'm going to go about trying to find an a and b that actually makes this happen. So to do that, I'm going to multiply by x plus 2 times x plus 1 both sides of the equation to get rid of the fractions. That leaves me with just 2x on the left side. And on the right side, the x plus 2's are going to cancel. I'm going to have a times the x plus 1 that's left over. The x plus 1's are going to cancel over in this fraction, leaving me with b times x plus 2. And now I'm going to pick a convenient x value that gets rid of a or b and lets me solve for whichever letter is left over. So to get a, for example, I'm going to try to get rid of b by plugging in an x value of negative 2. That's going to zero out this b term. And let's see, on the left side, I'm going to have negative 4. For a, I'm going to have, this is going to be negative 2 plus 1, so negative 1 times a, or negative a. B is just gone completely if I plug in negative 2. And this means then that a must equal 4. Okay, let's find the b value now. To do that, I'm going to plug in an x value of 1 to get rid of this a term. So plugging in 1 for x, or negative 1 actually, because I need negative 1 plus 1, I'm going to have 2 times negative 1, which is negative 2. On the right side, the a term is gone. I've got b times negative 1 plus 2, which is just 1. So then we just have negative 2 equals b. Now that I've found a and b, I'm going to go ahead and plug them in here and actually split this fraction up inside my integrand. So I've got 4 over x plus 2 inside the integral now. And then I'm going to have minus 2 over x plus 1 dx. Now I can go through and take the antiderivative of these. For this first fraction, I've got 4 ln absolute value of x plus 2. For the next one, this is going to be minus 2 ln absolute value of x plus 1. And don't forget the plus c. This is going to match up with, let's see here. Looks like answer choice D. We have 4 ln, we have minus 2 ln. The right stuff is inside. Yep, choice D. For this problem, I'm trying to take the antiderivative of this rational expression. Since there aren't really a whole lot of other things I can do here, my last resort is to use partial fractions. So I'm going to start by factoring this denominator out to see if I have unique linear factors. This factors into x minus 2 and x minus 4. And then I'm going to split that up into a over x minus 2 plus b over x minus 4. Now I'm going to multiply everything by x minus 2 over x minus 4, both sides of the equation. That gets me 1 on the left side, so that gets rid of that fraction nicely. Over here, I've got a times x minus 4, because the x minus 2's cancel, plus b times x minus 2, the x minus 4's cancel for that last fraction. At this point, I'm going to try to find a and b. To find a, I need to pick a value of x that's going to get rid of this b expression over here. So if I pick x to be positive 2, that'll cancel out b completely, because you're just doing b times 0 at that point. And then we end up with 1 equaling a times 2 minus 4, or negative 2a. So that means then if I divide that a must be negative 1/2. Next, I need to find my b value by getting rid of a. So I'm going to pick x to be positive 4 now. That gets rid of a, and I've just got b times 4 minus 2, or 2b. Still have 1 on the left side. So then we have b equals 1/2. At this point, I'm going to plug these back in to split my fraction up in the integrand. So I've got negative 1/2 over x minus 2 plus 1/2 over x minus 4. Going left to right and taking my antiderivatives, this is going to be negative 1/2 ln absolute value of x minus 2 plus 1/2 ln of absolute value of x minus 4 plus c. That doesn't give me anything that I have here. So we can simplify this a bit by taking a 1/2 out of both of these ln's. So then we essentially have ln of x minus 4 minus ln of x minus 2. So if I'm subtracting logs, I can put them together in a fraction by dividing. So I can write ln and then absolute value fraction x minus 4 on top, because that's the positive log. And then this one that's being subtracted, that means we're dividing by it. So this x minus 2 ends up in the denominator. And then we still have that plus c. That is going to give us, let's see, answer choice A. For this one, I'm trying to find the definite integral from 2 to 3 of this rational function. Since there's nothing else I can really do to simplify this, and I've got two unique linear factors in the denominator, I'm going to try partial fractions on this one. So I'm going to turn this fraction into a over x minus 1 plus b over x plus 2. Now I'm going to go ahead and multiply everything by x minus 1 times x plus 2. So that's going to give me just 3 on the left, because the denominator cancels out. And then over here, the x minus 1s are going to cancel. So I've got a times the remaining factor of x plus 2. And then for this b fraction, the x plus 2 is canceling. So I've got b times x minus 1. All right, so I'm going to solve this equation now for a and b. To do that, I'm going to pick a value of x that cancels out each of these letters. So if I want to get a, for example, I'm going to pick something that gets rid of b. So if I choose x to be 1, plugging 1 in here is just going to be b times 0, so that's gone. And I end up with 3 equals, well, this is 1 plus 2, so 3a. And then I know that a equals 1. Now if I want to find b, I'm going to get rid of a over here by plugging in negative 2 for x. So that gives me 3 equals, and then I'm going to have negative 3 times b. So dividing by negative 3, I have b equals negative 1. Plugging all that back in now and splitting up the fraction inside the integrand, I've got the integral from 2 to 3 of, now we're going to have 1 over x minus 1 minus 1 over x plus 2. It's kind of convenient the way that works out. So now taking my antiderivative, I've got ln absolute value of x minus 1 minus ln absolute value x plus 2. And evaluating that from 2 to 3. Now you could plug 2 and 3 in and do that dance right away. This time around, I chose to convert this into just one log, especially since I don't have any coefficients to mess around with. So I'm going to rewrite this. Since I'm subtracting the logs, I can divide the stuff inside. So this is really just ln absolute value of x minus 1 over x plus 2. So now I'm going to plug in 3 and 2. So I've got ln of 3 minus 1 over 3 plus 2 minus ln of 2 minus 1 over 2 plus 2, which I can simplify to, let's see here, this is going to be 2/5, and over here I've got 1/4. Since I'm subtracting these logs, I can move those into one big fraction. So I've got ln of 2/5 over 1/4, and then just same change flip, multiply by the reciprocal. We've got 4 times 2 over 5 times 1, so that's going to be 8/5, ln of 8/5, which gives me answer choice D.